Okay, today we're going over finding inverses of relations and functions. Basically, we're just going to go over finding inverses of functions. So first off, definition: a function is a relationship in which every input has only one unique output. We've gone over that before when we're defining functions. We're going to talk about a specific type of function. It's called a one-to-one function. A one-to-one function is a relation in which every input has only one unique output and every output has only one unique input. Essentially, if you guys remember our mapping diagrams, if I had those three inputs and I had one output, I could say that that is in fact a function because each of my inputs only have one output. So that still works as a function. However, that is not a one-to-one function because a one-to-one function has to have each input have its own output and each output have its own input. So your one-to-one functions are going to have to look like this, where this input has its own output and that output has its own input. Okay? These are going to be your examples of one-to-one functions. And that's essentially what that definition is saying. And then we're also going to talk about inverse functions. And the inverse function is the function that results from exchanging the input and output values. Exchanging the input and output values of a one-to-one function. So what we can get from that definition is, if you define something as a one-to-one function, that means that it has an inverse. So all one-to-one functions have an inverse. Okay? And then in order to define an inverse function, you have to exchange your input and output values. My input would be my x values, and my output would be my y values. So probably the most important thing that you guys will get from this lesson today is to find an inverse function, you have to switch your x and y. So I'm going to say that again because this is the most important thing that you can get from today's lesson is, to find your inverse function, you need to switch your x and y. Okay? And then something else about inverse functions is that they are symmetric about the line y equals x. Okay? If we're looking at a graph here, your line y equals x has a y-intercept of 0 and a slope of 1. So it's just going to be that line that cuts directly across the middle. Whoops. That wasn't my best line that I've drawn. Okay, so a lot of information on that first slide, a lot of important information on there. All right. Now, what do inverse functions look like? Well, we know that if we cube a number, so I've got x cubed there, its inverse is going to be the cubed root. And we know that just from solving equations. If you have a number cubed, you've got to do the cubed root to get rid of that when we're solving equations, right? So what they're going to look like, okay, is we've got our line in green here. That's our line y equals x. So our cube function is this one in blue, and our cubed root function is this one in red. And if you guys just take a second to look at these, you can see that those functions are inverses of each other because you can see they're symmetric about that green line. Okay? Whatever's on top is flipped over to the other side. Okay? Now, something else that we talked about was when we're finding inverses, you're going to be switching your x and y values, right? So let's look at some points that we know. If you guys remember graphing our cube function, we've got the point 0, 0, we've got the point 1, 1, and then we've got the point 2, 8. So I can graph this point here, and I know that that is 2, 8. Well, when I graph my cubed root function, I've got the point 0, 0, I've got the point 1, 1, and I've got the point 8, 2. Okay? Now, if you guys notice, looking at the point on my cube function up here and looking at the point on my cube root function down here, what happened with their x and y values? Their x and y values just switched. Okay? Instead of it being 2, 8, it became 8, 2. And that's, again, key for inverse functions. Your x and y values must switch. Okay? All right. Line test. We've gone over our vertical line test. That tells us if something's a function. There is also a horizontal line test. And a horizontal line test will tell you if a function is a one-to-one function. It works the exact same way as a vertical line test, but instead of using vertical lines, you're going to use horizontal lines. That's why it's called the horizontal line test. So, the horizontal line test, just repeating myself, tells us if it has an inverse. Okay? So, we've got a couple functions down here that we're going to look at. I just run a horizontal line across. And if you guys see when I run this horizontal line across, it touches at 2 spots. So that means that our parabola does not have an inverse. Okay? Versus if I look at my cube function over here, I can run as many horizontal lines across that and it will always only hit in one spot. So my cube function does have an inverse, which we just looked at that on the last slide. The cube function's inverse would be its cube root. Okay? Now, when we're graphing inverse functions, okay, if I have points and I want to know what the inverse of that function will look like, we just have to switch our x and y values. So if this point right here is a point on my function and I want to know what the inverse is, I simply need to switch their 2 points, which the 2 points were the same, which doesn't really change anything. So next point, I've got negative 3, 0. I need to switch my x and y, and my point then becomes 0, negative 3. I just switch my x and y's. Okay, I can graph that over here on this graph. You guys will start to see the inverse take shape. Again, I'm going to switch points. It becomes 1, negative 2. Graph 1, negative 2. And then the last one is negative 1, 4. That's going to become 4, negative 1. Graph that point up here. And again, you guys can see that these are inverses of each other because they're symmetric about our line y equals x. Whatever's up top flips down below. They are symmetric with each other. Okay, so again, key point with inverse functions is switch your x and y's. All right, so if we are given an equation, y equals 3x plus 9, okay, and I need to find the inverse of this function, my first step is the most important step when finding inverses. I need to switch my x and y's, okay? So instead of a y equals 3x plus 9, I have changed my x and y's position. Now, once I do this, I just need to solve for y. So I'm going to subtract 9 to both sides of the equation. Then I'm going to have to divide everything by 3. So if I take this 1 in front of it divided by 3, take a negative 9 divided by 3, I end up with y equals 1/3 x minus 3. Okay, I just switch my x and y's, and then I solve for y. Okay, if you guys graph this, I would start out with a positive 9, and then I've got a slope of 3, so I could go down 3 to the left 1. I don't really have the option to go up. Okay, and I can continue on that path, down 3 to the left 1. And this right here, that in blue, is my original function. Okay, now I'm going to graph my inverse that I just found. I'm going to plot my y-intercept at negative 3, and then its slope is 1/3. So I could go up 1 to the right 3, or I could go down 1 to the left 3. So there's my up 1 to the right 3. Could also go down 1 to the left 3. That would work as well. And that is my inverse function. Okay, again, this line right here, there's my y equals x. You guys can see that they are symmetric about that line. Okay, so again, key, switch our x and y's. All right, we'll do one that's a little bit more difficult. Okay, I've got y equals 3/2 x cubed plus 6. Okay, common mistake that I see people. They say, okay, I need to switch my x and y's. That is not switching your x and y. Okay? You just switch the x and y. I cannot bring that cubed. You cannot bring that cubed with that x. It's not attached to it. You just switch the x and y's. Okay? So when I switch them, I'm going to have x equals 3/2 y cubed plus 6. Okay? So see how the cubed stayed right here. I just switch my x and y. Okay? Now again, I'm going to solve this for y. Okay? If we solve this for y, I'm going to subtract 6 to the other side. Okay? Then I need to get rid of that 3/2. So I'm going to multiply both sides by 2/3. Show a little bit more work here. Multiply it by 2/3. That would cancel. Okay? If I multiply over here by 2/3, that 2/3 is going to have to distribute to both of those. Okay, so I've got 2/3 x. That's easy to see. If I'm taking 2/3 times 6, okay, it's a 6 over 1, so you have 12 over 3, which 12 over 3 gives me my 4 that I was looking for. Okay, and then the last step is I've got this y cubed here. How am I going to get rid of that cubed? I'm going to need to use its inverse, which would be the cubed root. So I have to take the cubed root of my y cubed, and I'm going to take the cubed root of this whole side right there. So I get y equals the cubed root of 2/3 x minus 4. If we look at the graph on these, again, you guys can see here in red, that's my original. Here in blue, that's my inverse. You guys can tell those are inverses of each other. They're reflections across my y equals x. Okay? We've got lesson practice problems. Finish up with those and then check with your teacher. Remember, biggest thing with inverses is switch your x and y values.